All right, hello again. My name is Brandon Clayton, the Algebra Guy, and I want to talk about use common divisibility test. So we talked about in our last lesson about finding multiples of a number: 2, 4, 6, 8, 3, 4, 3, 6, 9, 12, and so on. And I want to talk about divisibility because it works in tandem and very closely to multiples. So this should be very intuitive as we go through it. So by the end of this lesson, you'll be able to answer problems like this: is this number 3,765 divisible by 2 or divisible by 3, 5, or 10? So can you answer that now? But at the end of this lesson, you sure will be able to. So here's the question I want to answer: what is meant by divisibility? And how are multiples and divisibility even related? So let's look at the first one. What is meant by divisibility? Okay, so here's the definition. If a number, let's call it m, is a multiple of n, then we say that m is divisible by n. Well, what do you mean by that? Let's see if I put this up here. No. So what I mean by that, let's take something really simple. So let's take 72. Let's call 72. If a number m, let's call our m 72 to make sense of this definition. Is a multiple of n, let's say it's a multiple of 3. Then we say that m is divisible by n. So if 72 is a multiple of 3, then it should be divisible. So that means I should be able to divide 72 by 3 and get a whole number. 3 goes into 7 twice. 7 minus 6 is 1. Bring down my 2. 3 goes into 12 4 times. Without a remainder, I end up with 24. So this is divisible because the m, 72, was able to be divided by n to get a whole number. So let's look at some more to make sure we get this idea. How are multiples and divisibility related? A number is divisible by 2. So we talked about this, but in a backwards way, right? It's divisible by 2 if the last digits are 0, 2, 4, 6, 8. So we talked about we can identify if it's a multiple of 2 if the last digits were 2, 4, 6, 8. Now we're saying that it can be divisible by 2, which is the same thing because division and multiplication work backwards. So first we were saying we can do 2 times 1, 2 times 2, 2 times 3, 2 times 3 to get 6. So we can get all these numbers like 2, 4, 6, and so on. And what we're saying is that we can actually go backwards and say, well, we can divide by that 2 also. We can take the product and divide by 2, 4 divide by 2, 6 divide by 2, and get some whole number. In this case, it'll be 3, 2, and 1. So we're just thinking backwards to define the word divisibility. And for 3, if the sum of the digits is divisible by 3, then they're divisible. For 5, if the last digits are 5 and 0. For 6, if divisible by both 2 and 3. So there's another new rule. It's divisible by 6 if divisible by both 2 and 3. And 10 if the last digit is 0. So there are some divisibility rules. Let's go ahead and practice this, make sure we got it. Is this number divisible by, is 1290 divisible by 2, 3, 5, and 10? You know, I forgot that I wanted to tell you in my last lesson. It's supposed to be a bonus, so I'll say it now before I forget. What's the rule for something being divisible by 4? So I just want to make sure I include that as a little bonus here. So 4 is interesting. 4 means you can take the last 2 digits and make last 2 digits are divisible by 4. So if you had a big number like 728, so we take these last 2 numbers, say, oh, those last 2 are divisible by 4, so this whole thing should be divisible by 4. Actually, let me test that. I just came up with that right now. And let's see if that's actually true. Let me stop writing on my face. So let's put it, and we're doing 4, right? So we're going to do 728 divided by 4. 4 goes to there once. 4, 3, 2. 4 goes to 32 8 times. 8 times 4 is 32. That leaves me with a 0 here. Bring down my 8. And yep, 182. It's a whole number. Fantastic. So if you have the last two digits that are divisible by 4, then the number is divisible by 4. That's a little tip on divisibility by 4. Determine whether 1290 is divisible. So let's look at each one independently. So 2, is it divisible by 2? Well, is the last digit 02468? And we see that yes, it is a 0. So we're going to say yes. And we can check it because 1290 divided by 2 would give us a 645. Is the sum of the digits divisible by 3? So if I add up all these individual digits, 1 plus 2 is 3, 3 plus 9 is 12. That equals 12. And is 12 divisible by 3? Absolutely. So yes, this will work. Matter of fact, we can check and do 1290 divided by 3, and we get another whole number. Number 5, is the last digit 5 or 0? Yes, again, it's a 0, so yes, it'll work. We can check it by dividing it by 5, and we get another whole number. And 10, is it divisible by 0? Is the last digit 0? Yes, it is. And again, it's divisible by 0. We can check it by dividing it by 10, and we get another whole number. So, oh my, that's not what I wanted. But that's a pretty house. So, that's the way you can check using 2, 3, 5, and 10. That pretty house was by one of my daughters, by the way, in case any artists out there are thinking, that's incredible. So let's check and see if this one will work. Determine if this number is divisible by 2, 3, 5, and 10. So let's check and see if this is divisible. First, we look at our 2. We need a 0, 2, 4, 6 on the end, and we do not. We have a 5. We do not, so it's not divisible. And when you check it, you see you have a decimal remaining, so this is not divisible by 2. If it were, we would have had a nice whole number without any decimals, but this is not divisible. What about 3? Can we add them all up and get a multiple of 3? 5 and 6 is 11, plus 2 is 13, plus 5 is 18. 18 is divisible by 3, so yes. And you can check it here. Is the last digit divisible by 5 or 0? The last digit, yep, there's a 5 there. There's the last digit not divisible by, but is a 5 or 0. And yes, it is. So, yep. And is the last digit 0? Nope. So it can't be divisible by 10. When you try, you end up getting another decimal. And there's your indication that it's not divisible by that number, which is 10 in this case. So we know better than to say yes. It's not divisible by 10. And I put that one up twice. I believe this is our last one. 4962. Last number is a 2, so I know it's divisible by 2. And can I add them all up to get a multiple of 3? Let's see. 5. I got the wrong one up here. Well, good, because we get to work it ourselves. So let's work this one out ourselves. And we're going to ask about 2. Is it divisible by 2? And we're going to say, ew, that's not that pretty. Divisibility, is it a 0, 2, 4, 6, or 8? And we're going to say no. Oh, yes, it is. It's a 2. So it is divisible, and we can check that to see if it is. 4962, 2, 4, bring down my 9, goes in there 4 times, leaves me with an 8, 8, and that's going to be a 1. So, yep, we can check it and see. So what about a 3? Well, will these all add up to a multiple of 3? Let's see, 4 plus 9 plus 6 plus 2. 4 plus 9 is 13, plus 6 is 19, plus 2 more is 21. And 21 is indeed a multiple of 3. So I'm going to say yes, this is. And we can check it. Let's check it. 492, 4962 divided by 3 goes in there once. 6 times 3 is 18. 19 minus 18 is 1, bring down my 6. 3 goes into 16 5 times, giving me 3 times 5 is 15. 1 left over, bringing down my 2. 3 goes into 12, a beautiful 4 times. Nice, good whole number. So yes, it can, as we just modeled. Or we just checked. And please take the time to check your answers. So valuable. I know it takes a little bit of time, but the practice is good, and it's worth getting it right after putting so much work in. So for 5, it needs to be either a 0 or 5 on the end, which this one does not have, so it is not going to pass that test for divisibility. You won't be able to divide this and get a whole number. What about 10? Well, we need a 0 on the end, and that's not going to work. We just need a 0 on the end, and this was 0 and a 5 on the end, so that's not going to work. This is what I just showed. And we're going to conclude by asking, did we answer our question? Did we accomplish our goal? Yes. What is it meant to talk about divisibility? That's asking if a number can be divided equally to get whole numbers once you divide those two. How are multiples and divisibility related? Multiples are asking, what do you need to multiply by? Like 2 times 3 is 6. And divisibility is asking, can you go backwards? 6 divided by 3 is 2. So can I divide to get a good whole counting number? So thank you guys for tuning in. Again, my name is Brandon Clayton, and I will see you next lesson.